Balance the following equation. Whenever I balance the equation, I always make a list of all the elements present in the reaction so that I can tally how many I have of each element on either side of the equation. One thing I notice in this equation, I see phosphate on the left and phosphate on the right, and I don't see any other phosphorus or oxygen anywhere in the equation. Likewise with CN. I see it on the left and the right, both present as CN, and I see neither carbon nor nitrogen present anywhere else in the reaction. So when I write my list of elements, I'm actually going to leave the phosphate and the cyanide written as those polyatomic ions. Now, if you expand it and write it as phosphorus, oxygen, and carbon and nitrogen, you will still get the exact same result. Sometimes we can't do this. If, for example, I had phosphate on the left side, but on the right I had phosphorus and water and some other reactants or products, then I wouldn't be able to keep them written as the polyatomic ions. So this is just a little bit of a shortcut when you notice this is happening. So here I have hydrogen, phosphate, sodium, and CN. So on the left side I have 3 hydrogens, 1 phosphate, 1 sodium, and 1 cyanide. On the right side of the equation I have 1 hydrogen, 1 phosphate, 3 sodium, and 1 cyanide. So I see that I have a couple of things that are out of balance. So I'm going to start with the hydrogen for no other reason than because it's listed first, and I'm going to add a coefficient in front of the HCN so that now I have 3 hydrogens on the right, but that also changed the number of CNs on the right to 3. So now my hydrogens and my phosphates are balanced, but the sodium and the cyanide are not. So now I need to add a 3 in front of NaCN. So that gives me 3 sodiums and 3 cyanides, and now it appears that my equation is balanced. And so I can go back and review this just to make sure, and we see we have 3 hydrogens on the left, 3 hydrogens on the right, and I'll actually go through this elementally so that way you can see that it does work to leave these as polyatomic ions when the polyatomic ions remain intact from the left to the right. So here I have phosphorus, 1 phosphorus on the left, 1 phosphorus on the right, 4 oxygens on the left, 4 oxygens on the right, 3 sodiums on the left, 3 sodiums on the right, 3 carbons and 3 carbons, 3 nitrogens on the left, and 3 nitrogens on the right. So I see that I have a balanced chemical equation, and always remember to go back and check at the end just to make sure you haven't lost something along the way.